In this video, we're going to talk about the molecular and empirical formulas. So just to start out with, molecular formula is going to be the actual chemical formula of a molecule or a compound, and that's how exist those compounds in nature. However, when we look at the empirical formula is going to be the simplest ratios of the subscripts of the molecular formula. So let me take a few examples and that clarify the difference between the molecular formula and the empirical formula. So suppose I have this C8H18, and that's also called octane. That's the actual formula for octane. Now the simplest formula, which is going to be the empirical formula for this octane, would be I want to divide both of those subscripts by the highest possible integer. And in this case, that's going to be only 2. So when I divide both of those by 2, this is going to be C4H9. So that's going to be the empirical formula for the octane. Well, let me take another example. What if I have C6H6, and that's called benzene? The simplest formula or the empirical formula for this is going to be CH, because I can divide both of those subscripts by 6. Well, let's take a couple of other examples. What if I have a sugar, which is C6H12O6? So when I divide, the highest number that I can divide all those subscripts is going to be 6. And when I do so, the simplest formula becomes CH2O. So that's going to be the empirical formula. What about something like magnesium sulfate? So I have MgSO4 to be the formula for the magnesium sulfate. And seems like this is already in the simplest form. I can't really reduce it anymore. So that means at that time, this empirical formula would be the same as the molecular formula. Well, I can take another example maybe. What if I have something like MgCl2, so that's magnesium chloride, and this is already in the reduced form in the subscripts, so the empirical formula for that is also going to be MgCl2. So the common thing between the last two molecules that we just talked about, they're actually ionic compounds. So a lot of ionic compounds have the same empirical formulas and the molecular formulas, and there are some other covalent compounds that do have the same molecular formula and the empirical formula. So you could technically have the same empirical formulas and the molecular formulas, but obviously not always. Okay, so now the question is, how do you really calculate the empirical formulas and then eventually the molecular formula? So in this video, we're going to first focus on calculating the empirical formula, and once we know how to calculate the empirical formula, I have another video where I talked about how you go from calculating the molecular formula from the empirical formula. So let's look at this question. It says, if I have 1.45 grams of phosphorus and it's burned, so when it's burned, it's going to be burned in the air, so then it makes some sort of oxide, so phosphorus oxide, and we have to actually figure out what the formula going to be for that oxide. So that could very well be the molecular formula, but we just don't know, so we're just going to stick to finding only the empirical formula. If they do ask you to calculate the molecular formula, they have to actually give you the molecular mass. Okay, so a lot of these oxides empirical formulas can be calculated by burning those metals or not metals in air, because when you burn those in the air, what's going to happen, they will grab in the oxygen. So for example, if I want to write down an equation for this, it's going to be the phosphorus plus an oxygen, and that's going to make uh, some sort of oxide, and I don't know the formula for that, so it's you don't really have to worry about balancing it. So let's say we get X here, and for oxygen I get a Y here. So my job is to figure out what X going to be and what Y going to be. Okay, so far we know we have 1.45 grams of phosphorus, and we are told we have 3.32 grams of pxOy, or another way of saying we got 3.32 grams of this unknown phosphorus oxide. So this oxide actually contains only two types of elements. It got the phosphorus on it and it got the oxygen. And we already know the mass of the phosphorus, so we can actually easily calculate the mass of oxygen. All right, so let's say, can write that down here. So the mass of oxygen is going to be 3.32 minus 1.45. So let's see what that comes out to be. So 3.32 minus 1.45. Okay, that's going to be 1.87 grams. Okay, so once you know the grams, the masses of your elements that makes up the compound, the next step you have to do is find their moles. So let's start with finding the moles for the phosphorus. Okay, so let's start with writing down 1.45 grams of phosphorus, and then um, we're gonna have we're gonna need to change this to moles of phosphorus. So I would put this moles of phosphorus on the top, and I want to get rid of grams of phosphorus, so put the grams of phosphorus on the bottom. And then what number we want to have here? Well, if you recall the mole concept, anytime you're going from grams to moles, you use the atomic mass or the molar mass. So we'll have 1 here. The atomic mass for phosphorus is going to be 30.97. So 30.97. Okay, so when we do this calculation, it's going to be 1.45 divided by 30.97. So it's going to be 0.0468 moles of phosphorus so far. So here the grams cancels out, and that's what we really want to have. Okay, now we're going to do the same thing for the oxygen. So we're starting out with 1.87 grams of oxygen, and then we want to convert this to moles of oxygen. So we'll have a very similar step here, but now we're going to be using the atomic mass of oxygen. So I'll have 1 mole of oxygen divided by the atomic mass of oxygen, which is 15.99 grams of oxygen. Okay, so then grams of oxygen cancels out. Let's do the math here. So 1.87 divided by 15.99, and that's going to give you 0.117 moles of oxygen. Okay, so once you find the moles from the grams, the next step, and make sure you memorize what the step's going to be, and it's very easy to forget these steps. The next step is to divide both of these moles by the smallest moles you have gotten so far. So in this case, if I look at it, my smallest moles is going to be 0.0468. So actually I want to divide both of these numbers by 0.0468. And the second number by 0.0468 as well. And let's see what numbers we get in that case. Okay, so the top one is just going to be 1, so we got 1 mole of phosphorus. And then for the oxygen, it's going to be 0.117 divided by 0.0468, and that's going to be 2.5. So we got 2.5 moles of oxygen. Now, at this time, there is a good chance you'll have the integers or the whole numbers for both of the moles or all the moles that you're dealing with. If you have more than 2 elements, then you'll have the whole numbers for all the moles. But then there are going to be times when you don't have the whole numbers. Like in this case, we have 2.5 moles for the oxygen. And if you don't have the whole number, then you want to pick the smallest integer that you can multiply this decimal with so that you get a whole number. So what's the smallest integer you want to pick that you can multiply this 2.5 with to get a whole number? Well, that's just going to be 2. So that's the next step, but you want to make sure you memorize if you don't get a whole number. So it's 2.5 times 2, so that's going to be 5 moles of oxygen. Now, if you multiplied the moles of oxygen by 2, you want to stay consistent and multiply the moles of phosphorus by 2 as well. So I'll have 1 mole of phosphorus to begin with, multiply that by 2, and it's going to be 2 moles of phosphorus now. Okay, so now you have the whole numbers for both of the moles of phosphorus and the oxygen. So that means you can go ahead and write down the formula for that. So I have 2 phosphorus, so it's going to be P2, and I have 5 oxygen, so it's going to be O5. So this is going to be the empirical formula for this particular phosphorus oxide. So now you have found the value for the phosphorus, the moles for the phosphorus and moles for the oxygen. And now if you want to go ahead and write the balanced equation, you can do so. So I'll have a phosphorus plus O2, and that goes on to make P2O5, because now you know the formula. And then it's all about balancing it. So, well, I have a 2 here for the oxygen and 5 here for the oxygen. So maybe multiply those by one another. So you got 2 in front of here and 5 here. That makes 4 phosphorus on the product side. So that means you can put 4 here. So that's going to be the balanced equation at that time. Okay, so make sure you memorize these steps, and if you practice enough, you'll have them automatically memorized. And I'll have another video posted where you actually calculating the empirical formula and then the molecular formula.